Every package that Amazon ships by rail passes through a place like this. Every tank of gas that arrived at a fuel depot by freight train. Every car part, every roll of steel, every grain shipment that crossed the country. At some point on that journey, a rail car that was part of one train had to become part of a different train, heading in a different direction, toward a different destination. Somebody had to sort it. And in the middle of the country, in a city of 25,000 people in western Nebraska, that sorting happens at a scale that most people never think about and almost nobody has seen. The problem is this: a freight train arriving in North Platte from Chicago might be carrying 200 rail cars. Some are going to Los Angeles, some are going to Portland, some are going to Wyoming's coal mines. They all arrive together. They cannot all leave together. They have to be separated, sorted, and reassembled into new trains heading in different directions. And they have to do it fast, because another train arrives every 14 minutes, and there is nowhere to put it if the last one hasn't been processed yet. Do this wrong, and the problem doesn't stay in Nebraska. It spreads backward through the network, train by train, until the entire northern half of Union Pacific's system is backing up. At 2 in the morning, a hump operator is watching 4 railcars roll downhill at the same time. Each one weighs up to 70 tons. Each one is heading toward a different track. None of them have engines. The operator has roughly 12 seconds before the first one needs to be directed into the right slot, and there are 113 other slots it could go into by mistake. Outside, the temperature is below freezing. Inside the control tower, the screens show 47 cars still waiting behind the hump. This is the solution to the problem. It is called the hump, and it is the hidden mechanism at the center of the largest railroad classification yard in the world. A rail car that enters Bailey Yard as part of one train can leave 90 minutes later as part of a completely different train, heading in a completely different direction, without anyone ever touching it by hand. 4 things make that possible, and 3 of them are invisible to anyone who doesn't know what to look for. The slope of the hump itself, the retarders in the track that control each car's speed, the 985 switches that route each car to its assigned destination, and the operator in the tower watching all of it happen at 4 cars per minute. This video is about how those 4 things work together, and what happens when they don't. Every 24 hours, an average of 139 trains and more than 14,000 railcars pass through Bailey Yard. Of those, roughly 3,000 cars are fully reclassified, meaning they arrive as part of one train and leave as part of another. The rest are serviced, inspected, and sent on their way without being broken up. 1 out of every 10 freight trains Union Pacific runs each day passes through this yard. Bailey Yard sits at the exact geographic midpoint between Denver and Omaha, which is not a coincidence. It is the crossing point of Union Pacific's east-west main line, the overland route, the original transcontinental corridor, and its north-south routes into Wyoming and Kansas. Traffic from Chicago and Kansas City converges here before it spreads west and north. If you drew a map of Union Pacific's network and found the place where the most routes intersect, you would find North Platte, Nebraska. You would find Bailey Yard. If that yard stops working, the problem doesn't stay in North Platte. It travels east toward Chicago and west toward Los Angeles at the speed of a delayed freight train. Running this operation requires 2,600 people in North Platte: engineers, mechanics, welders, inspectors, car repairers, fuel technicians, and the operators who run the humps. They work in shifts around the clock every day of the year because the trains do not stop for holidays or weather, or the fact that it is 2 in the morning. Nobody says, "What do we do next?" One track department employee told Trains magazine, "The answer to that question is always the same. The next car, the next train, the next 14 minutes. The hump operator is the most visible link in the sorting chain, but the chain starts before any car reaches the hump. When a train arrives on one of the receiving tracks, a car rider, a worker who physically rides the cars as they are separated from the incoming train, helps break the consist apart. Car inspectors walk the length of the train looking for defects. bad brakes, loose connections, damaged undercarriages. Cars that pass inspection go to the hump. Cars that don't go to the repair facility. The system needs clean input to produce clean output, and the inspectors are the filter. On a 200-car train, that walk takes time, and it happens regardless of what hour the train arrives. The inspector who finds a defective car at 3 in the morning in a Nebraska winter makes the same call as one who finds it at noon in June. The car goes to repair. The rest move forward. The system needs clean input to produce clean output, and the inspectors are the filter between the arriving network and the sorting machine. The hump itself is a precisely engineered slope, 34 feet high on the east side of the yard, 20 feet high on the west side. A locomotive pushes a car to the top of the hump at a controlled speed. When the car reaches the crest, the locomotive stops. The car doesn't. Gravity takes it down the other side, and from that moment forward, the car is on its own. The retarders, brake-like devices embedded in the rails, slow the car to a precise rolling speed as it descends. Too fast, and it hits the cars already parked in the bowl too hard. Too slow, and it doesn't make it all the way to its assigned track. The operator adjusts the retarder pressure based on the car's weight, the wind, the temperature, and the condition of the rails. 4 cars per minute, every minute, 114 possible destinations. The fuel and service center processes more than 8,500 locomotives per month. Union Pacific operates one of the largest locomotive repair facilities in the country at Bailey Yard, running 24 hours a day. Overhead cranes and elevated work bays allow technicians to access locomotives from above, reducing the time it takes to service a unit between runs. Half the westbound coal trains that pass through get a fresh set of power here before heading to Wyoming's Powder River Basin, the same coal that the SD-70 Mack locomotives, covered in an earlier video on this channel, were specifically designed to haul more efficiently. The wheel defect detector is a technology that Union Pacific developed internally, and that, as of the time of research for this video, does not exist anywhere else in the world. It uses ultrasound to inspect wheels while the car is still moving through the yard. The system can identify subsurface cracks and defects that a visual inspection would miss, the same category of failure that caused the Eschede disaster in Germany and the CN Plaster Rock derailment in Canada. Bailey Yard replaces approximately 10,000 wheel pairs per year. Some of those replacements happen without the car ever leaving the track, using equipment that can swap a wheel set in place. What happens when Bailey Yard clogs is not a local problem. The yard sits at the junction of Union Pacific's main east-west corridor and its north-south routes, the point where traffic from Chicago and Kansas City converges before it spreads west toward Wyoming, California, and Oregon. A train that can't be processed at Bailey Yard doesn't disappear. It waits. And while it waits, the receiving tracks fill up. And while the receiving tracks fill up, the trains behind it on the main line can't enter the yard. And while those trains wait on the main line, they block other trains behind them. The ripple propagates outward at the speed of freight. Dan Check put the stakes directly. If this yard starts to clog, problems will ripple out across the entire north half of the Union Pacific Railroad. The northern half of Union Pacific's network serves Wyoming's coal mines, the Pacific Northwest ports, and the Canadian border crossings. A yard that processes 14,000 cars a day and handles 1 in 10 of Union Pacific's daily freight trains is not a facility with much slack in the system. The schedule that moves a coal car from Wyoming to a power plant in Illinois, or a container from Long Beach to Chicago, is built around Bailey Yard, processing its portion of that movement within a window as tight as 90 minutes per car. Miss the window and the chain breaks. Every train that has moved through the stories on this channel has passed through a yard like this one, or will. The coal that the SD-70 Mack locomotives pulled up the Colorado joint line was sorted somewhere before it reached those grades, classified into a consist, assembled on tracks like the ones in Bailey Yard, sent west as a unit train that arrived at the mine without the cars ever having to be reclassified again. The freight that the empire builder shares its tracks with was broken up and rebuilt at some point in its journey. The containers moving through intermodal hubs were last touched by a classification system that sorted them out of one train and into another. Bailey Yard is not at the beginning of the supply chain or the end. It is in the middle, the point through which a significant portion of the American freight network passes on its way from somewhere to somewhere else on a schedule that the rest of the network depends on.